Kumar. I have completed my project successfully in Ford. My partner is E. Delhi Babu. Our project title is Reduction of Low Speed Rundown Torque Failure in DV4 engine during cold test. My project has been done in Chennai. This my aerial view of my Ford Chennai plant. The Ford company has a few shops. The first shop of car making is stamping, body shop, paint shop, TCF, quality testing, etc. By finishing these all steps, the car successfully comes out with 100% quality and assurance to the customer. Currently, Ford is manufacturing 5 models. You can see that in this slide. Firstly, my project has 5 phases: define, measure, analyze, improve, and control. First phase is define. This is about what is the project and why this project is done and how it is done. Problem statement: during the last 6 months in FTT, that is engine assembly plant, for last 6 months 93,000 engines were produced, and in that 102 engines were affected, and it is not passed in the quality test. So there's a loss of about 10 lakhs by this 102 engine failure. So our project plan is about completing it within 3-4 months time duration. Project benefits: improving FTT first time run through in the cold test, reduce the repair cost, reduce the repair time, eliminating fatigue caused by repair, improving cold test efficiency of RR, save time and manpower, eliminating rework, delivering quality products. LS run torque failure difficulties: not able to identify at the beginning of the process. It can be found only at the end of the quality test assurance. Repair cost is increased in old engines. As I said, some amount of 10 lakhs has been wasted during the last 6 months. So what is cold test? Cold test is a major engine quality assurance procedure. The unfired engines are pulled by an electric 3-phase induction motor and tested for correct functioning at predefined engine speeds. The test covers engine assembly itself, the wiring harness, and the connected sensors, actuators. Compared with hot test, in which engine runs on fuel, cold test costs a lot less in terms of ventilation, exhaust scavenging, cooling, fire prevention, and noise protection. A cold test takes only 20% of time needed by the hot test. This boosts efficiency and cuts production costs. Cold test process engine takes in 75 seconds. The cold test parameters: 4 types of process takes place. Static: 25 parameters are there. In 800 rpm the engine is run, and 120 rpm the engine is run at 7 parameters. OPS, oil processing switch. While testing engine at 800 rpm, the major issues such as intake, vacuum pressure, oil pressure, crankshaft position, cylinders identification sensor, NOx sensor are tested. LS rundown torque failure occurs if the engine fails to produce torque spec between 70 to 140 Newton when run at 800 rpm. This cold test flowchart diagram of how the cold test is processed. Engine step down per cost. The total average engine step down per month cost is this, as you can see in the diagram. The engine repair cost 153k, that is 1,53k for a average engine step down cost per month. Then RR study: repeatability and reproducibility is nothing but the ability of the machine testing and the man who is using the machine testing. These two things are studied, and it's taken under process. Then the next phase, measure. In that we had a cost and analyze effect diagram. You can see the diagram. Next is analyze phase. The major severity was in PCR zone, piston conrod zone. So we actually tested 7 times, and we have the remarks for this. This is big damage on upper compression ring groove, dent in upper compression ring groove, slight impression mark in ring groove. So every problem is within the piston conrod section only. So you can see that red circles where some minor scratches and dents are occurring on that piston, mainly nearly that ring groove and that piston top. So while stuffing and restuffing the piston, due to some damage, due to some hard stuffing, the damages are more. This is also one of the testing results where you can see the yellow round. In that you can see small dents. so improve. So what can we do for these piston contour mesh problem is that implementation of OP 4000 in incoming quality. It's actually visual inspection of piston damage. Every piston damage batches, every piston boxes are not 100% quality assured. So we actually implemented two fellows for visually inspecting the piston for every batch that is been coming from the incoming quality. Next, again we made a new jig that is on the right hand side, and the left hand side is the old jig. Here in the right hand side we gave the design of a open type jig. And by implementing this new jig, we had less ring wear. FTT was first time through was achieved and piston damage was improved. Next, the modified jig is made of hardened steel with nylon coating material, and it was accepted by the process team. We made a jig which has more clearance around the piston, quick and easy fitting. Piston pop out was reduced. Okay, this is about the benefits of nylon coating: protection, abrasion resistance, and impact resistant and long life. Control: we had a control of 102 engines to 60 engines. That was previously 102 engine was repaired for this not function, and now only 60 engines were not function. So by this project we improved FTT, production rate is increased, line stoppage was eliminated, eliminating rework, delivery of quality products. This is a conclusion. FTT was improved from 92 to 95%. You can see here. Thank you.